Hello everyone, welcome back to Spectrum classes. In this video, we are going to discuss about the calculation part of vitamin C or ascorbic acid using iodometric titration method. I have already uploaded the video on the experiment how to determine the vitamin C by using iodometric titration method. But I got many queries related to the calculation part. So students find it difficult how to calculate the vitamin C concentration based on our solutions which they prepared by themselves, right? So I am just going to discuss a general method so that anyone can calculate their concentrations and the concentration of vitamin C. So what I did or I performed in the experiment was based on the iodine solution, but many of the students are performing this titration with potassium iodate solution, that is KiO3 solution. So here I am just going to give you the calculations related to the potassium iodate, and I have divided this video in three different parts. First is standardization of sodium thiosulfate with potassium iodate solution. Second is calculation based on mole concept, because many of the students are very much confused with this mole concept, so I give you alternative method also. And the third part is calculation of vitamin C by the direct titration method. So we will minimize the calculation part here again, right? So I will first start with the reactions. So the reactions involved for the standardization of sodium thiosulfate is this. So here I've just written, this is our potassium iodate. So I just write in the ion form, right? Balancing of this equation, that is again an important point. So students are find it difficult how to balance this equation. So there is a very simple method to balance this equation. KiO3 is your initial ingredient, right? So this is your first salt which you need to prepare. Now from this Ki, you know that you will get iodine plus you have this oxygen. So just to balance this oxygen first, so 3 oxygen is there, and for balancing this or to forming the water you require 6H plus. So 6H plus must be there. If 6H plus is there, so this is come from HCl solution, and in that case you are having 6Cl minus. So now the second part is to balance this Cl minus. How you are going to balance this Cl minus? So you are preparing 6KCl, right? Now coming to the part 6, how we are getting this 6KCl? So 1 comes from this, now rest 5 will come from 5Ki, right? So why this 5Ki? Because if I multiply it with some value, then my oxygen will change. I didn't do that, right? So 5K from this and 1K from this, so 6K will come in this manner. Now we are just going to add our iodines. So iodines are 6 iodines. I2 is there, so multiply this by 3. So I hope you get, this is 1, this is 5, this is 6, and this is 3, and this is again 3. So I hope you know from where these coefficients come in this equation. The second equation is this iodine which is released over there, that will react with the sodium thiosulfate. I again wrote this sodium thiosulfate Na2S2O3 in this ionized form, right? So here we are having this, and 1 iodine reacts with, or 1 mole of iodine reacts with 2 mole of thiosulfate. Since this S2O3 will becomes S4O6 2 minus, and here we are having 4 minus. So where this 2 minus will go? So 2 iodine will be formed over there. So I hope you understand the balancing of charge and balancing of coefficients. So here this is the reaction. Now in the previous equation we are having 3 iodine which is released, and in the second equation we are having 1 iodine. So just to balance this equation, we just simply go to multiply this equation by 3. So if I multiply this equation, then what I will get? 3I2 plus 6S2O3 2 minus. I will get 6 iodine and 3 this. So here 3 iodines will react with 6 S2O3. If I add these two equations, then what I will get? I will get this. So first equation, IO3 minus plus 5I minus plus 6H plus and plus 6 S2O3 2 minus, and this will form this product on the right hand side. Say this and this. This I3 will cancel out by this I3 from these two equations, right? Now, if we are just going to calculate the number of moles of iodate with this sodium thiosulfate, then what I need to do? I need to calculate the change in oxidation state. That is my important point, change in oxidation state, right? So how we are going to calculate the oxidation state in this iodine? I am just going to tell you how we are going to calculate. Say I want to calculate for this iodine. So I plus 3 into minus 2. For one oxygen we are having minus 2, and this will equal to R minus 1, the charge which is remains there on this ion, right? So this X you will get plus 5 after solving, and I have already calculated the oxidation states. So change in oxidation state will be equal to your left hand side plus 5 minus your right hand side minus 1. You will get plus 6. So this is the change in oxidation state from where we started minus from where we reach. Fine. So this is I have written over there. Secondly, what about the change in oxidation state of this? So here this sulfate reacts with iodine and then it forms this S4O6. So here the oxidation state of sulfur is plus 2 for per atom. This is per atom. Here for sulfur it is 2.5. I can calculate for you. This is 4x plus 6 into minus 2 is equal to minus 2. So what you will get? X is equal to plus 10 upon 4, right? So this will be equal to 2.5. Here you can see. Similarly, we have calculated the oxidation state of sulfur atom in this S2O3, right? So change in oxidation state in this manner we get 0.5 per sulfur atom. This is for one sulfur. Here you can see one sulfur, one X is there. If I multiply it by 2, then what I will get? I will get 1 per 2 sulfur atoms. Now you can ask me a question, why for 2 sulfur atoms? Because on the left hand side I am having S2 and on the right hand side I am having S4. I can do this. There is a change in oxidation state per 2 sulfur atoms is 1. Fine. I hope you understand this concept. Now calculation part. So calculation will be done in the redox titration. We are doing the calculation in this manner. We are simply multiplying the coefficients over there. So the coefficients here are, this is for 1 and thio is 6. What is this A1 and A2? So this A1 and A2 means the number of electrons gained or lost in half reaction, right? So in this case we are gaining 6 electrons and in this case we are gaining 1 electron per 2 sulfur atoms. So here either way you can do, or simply here is the coefficient is 1 and here the coefficient is 6. So if I am just writing this for iodate IO3 minus, then cross multiply this 6 for IO3 minus and 1 for hyposolution. So cross multiply with the coefficients, or simply you can multiply with your number of electrons gained or lose. Now we are moving further. I am just going to show you how we are going to prepare the solution and how the reactions will go on. So in my previous case, I have written one reaction in which potassium iodide is there, KiO3, and some I minus is there, that is Ki is there, plus some H plus ions are there, it means HCl is there. So here you can see the preparation of solution have these three ingredients. So here I have written the amount of KiO3 which you have added in a given flask. Say this is 250 ml, and 3 grams of potassium iodide you have added. You have added 5 ml of 6 molar HCl solution, and make up, after adding all these and dissolving the salts, you make up to the mark with deionized water. So this is how you are going to prepare your solution of iodate, potassium iodate. Fine. And similarly, you can prepare the solution of your sodium thiosulfate. So take some amount of sodium thiosulfate, dissolve it in the desired amount of volume, and then dissolve it properly, thoroughly with deionized water, and fill that solution into your burette. This is the known amount of or known concentration of sodium thiosulfate. Now, coming to the next point. So if you want to calculate the molarity of the solution, how much molar solution you have prepared, so simply put all the values in this formula: weight taken, molecular weight, volume taken, and if it is in milliliters, then you divided it by 1000 to convert it into liters. So in this manner you can know the concentration of your iodate solution, potassium iodate solution, as well as your sodium thiosulfate solution. Now coming to the next point. So take 20 ml, 30 ml, 50 ml, whatever you think of, take that much amount of volume of the known concentration of potassium iodate. One more thing, if your Na2S2O3 is not standardized, then you can use this solution as primary standard to standardize your sodium thiosulfate solution. Right? I am just going to show you. So here I have written the calculation part. So how you are going to do your calculation. So A1 is equal to 6, A2 is 1. If your this IO3 minus is there, and if you are putting 1 mole of KiO3 produces 3 moles of iodine, and 1 mole of iodine reacts with 2 moles of sodium thiosulfate. So this I3, if I multiply this equation by 3, then I will get 6 moles of this, and similarly M1V1 upon 1, M2V2 upon 6. So the coefficients which are there for thio, there was 6, so divided it by 6, or you can simply multiply it by 6 and multiply it by 1. Whatever you feel, you can write down in that simple way, right? So but the actual concept is number of electrons gained or lose you must understand, or your equations are balanced. Now coming to the standardization part. If your sodium thiosulfate is not standardized, then you have taken 20 ml of your potassium iodate solution in the conical flask and now titrating it with Na2S2O3, then what is going to be happen? So for this 20 ml, I'm just going to show you some lab activity also. So put all these values here. So this is your concentration of KiO3 which you have prepared, taken 20 ml of solution in the conical flask. So molarity of sodium thiosulfate we need to calculate. The amount of volume is consumed is this much, and you divided it by 6. As I told you earlier, this is by 1, this is by 6. Divide by their coefficients in the equation. Now the molarity of sodium thiosulfate is this much. But in some of the texts, some of the students are doing in this manner and they get confused what they are doing actually. So I'm just going to explain this. This is the second segment of this video. So calculation in the according to mole concept and direct calculations will also be discussed at this point. So moles of KiO3 students are doing in this manner. Say you have taken X grams of this, say 0.54 grams you have taken, and the molecular weight is this much. So instead of this, you can write down 0.54 grams divided by this. So this many moles of potassium iodate. Now you have dissolved this many moles which are from this equation that are going to be dissolved in 250 ml of water. So what need to be done? So say this is equal to Y. So Y moles of this KiO3 dissolved in this liters. Liters how? Liters. So this is 1000. 250 ml divided by 1000. So you get 0.250 liters. Now, if you take 20 ml for the titration, then how many moles? So say this is equal to Z moles. So Z moles into this much ml. This divided by 1000. So how much you will get? So you will get 0.020 liters. So this much of moles of KiO3. So this type of calculation students are doing and they get confused with this. So you can do this alternative method. Weight, say 0.54 grams. You want to calculate the molarity. Molecular weight is 214 grams per mole and your volume is 250 ml and 250 ml divided by 1000 ml per liter. So it will convert it into liters. Fine. So here you can see you will get the same value as you did in your this part. So this is the same answer you will get. Now coming to the next point. So this we have carry forward from the previous equation. So in the reaction number 1 where KiO3 plus I minus plus H plus will gives you 3 iodine. So this many moles multiplied by this 3. So that I multiplied there only. So you can write down in your notebook and then you can understand how we are going this. So this is this many moles of iodine and this many moles of iodine on titration with sodium thiosulfate. So this one iodine requires 2 moles of sodium thiosulfate. So I multiplied it by 2 and this many moles of sodium thiosulfate. And the final volume which is required we need to divide by that also. So we get this much. And what you remember, we get similar result with simple 2 equations. Here I am just going to show you here. So simply you put all the values there only, no molarity, no moles, nothing is required. Only you know what solution you have taken for potassium iodide, how much solution you have taken, how much volume in liters it requires for this titration, and simply put this equation because this equation will remain same for iodate and sodium thiosulfate solution. Nothing is changed. Simply put your values in this equation, you will get the result directly. So here again I have just shown all the things. You simply put your values in this equation and then get the same result. Now coming to the third part of this. In the first part, what we have done, we have taken 20 ml of this molar potassium iodate solution and titrated it with sodium thiosulfate solution. Similarly, what I have done over here, I have taken the same solution, this one, same solution, but I additionally added 5 ml of this vitamin C solution to this solution. Now what you are expecting going to be happen? Say 20 ml of this solution. Similarly 20 ml of this solution again. Same thing is repeated over there. Now I have added additionally 5 ml of vitamin C solution, which I distinguished with light yellow color. And if I mix these two, then this vitamin C reacts with the iodine which is present over there. So in this case, we are having less amount of iodine as compared to this one. This is having more iodine as compared to this because some of the iodine part reacts with the ascorbic acid. Fine. So we get ultimately this kind of light color. Now how we are going to do the calculations directly? So here I have just written the equation. So some students get confused again over there. So iodine on reaction with this produces this 2I minus. What does it actually means? It means some of the ascorbic acid, this ascorbic acid reacts with the iodine that produced in the reaction number 1. And it consumes that iodine. So less iodine is left for titration with this sodium thiosulfate solution. I'm just going to show you here. So in the first case, we are having this much of the volume of sodium thiosulfate required to react with iodine present in the equation number 1. But after, in the second case, we require less amount of sodium thiosulfate which is required to react with the present iodine. So less amount means less iodine is there. So where is the rest of the iodine goes? So rest of the iodine reacts with the ascorbic acid. How much iodine reacts with the ascorbic acid? So if I subtract this second one from the first one, then I get this much of volume. So we can directly say, rather saying how much sodium thiosulfate is required to react with iodine, we can simply say how much sodium thiosulfate is required to react with the vitamin C. Here, this is the direct method, fine. And since 1:1 reaction is there with vitamin C, iodine on reaction with vitamin C, it produces 2I minus. And since 1 iodine reacts with sodium thiosulfate, S2O3, to produce 2I minus, so there is 1:1 relation is there. So it means if we calculate the amount of iodine reacts with the sodium thiosulfate, then we can directly equate it with the vitamin C. I hope you understand here, but again I am saying this in this manner. So how much volume of vitamin C I have taken? I have taken this much amount of vitamin C. So here 5 ml of vitamin C taken. Its concentration is not known to me, but the concentration of sodium thiosulfate is known to me from the previous experiment. And the volume consumed against this vitamin C is this much. And what about the coefficients? So this coefficient is 1 and 2 because 1 iodine reacts with 2 sodium thiosulfate and 1 iodine reacts with 1 vitamin C. Right? So 1 iodine is equal to 1 vitamin C and 1 vitamin C is equal to 2 sodium thiosulfate. So their coefficients are in denominator. Either you can put this in denominator or you can simply cross multiply it. So in either way you can do here. So this is on solving we get this much molar of your vitamin C solution, right? But if I prepare this vitamin C solution on dissolving this much grams of vitamin C powder or ascorbic acid powder in 100 ml, then how I am going to calculate how much this gram of water contains vitamin C. So this is the way of calculation. So with molarity which we get from this, you simply put over here, multiply it with molecular weight of vitamin C or ascorbic acid. So this is the multiplication. So simple formula, weight of vitamin C, right? And this is in grams per liter. So 1 liter of solution contains this much grams of vitamin C. I'm just writing it in this manner, fine. So 1 liter, here I have written this in this manner, So 1 liter means 1000 ml contains 1.57 grams. But my solution is 100 ml. So this 100 ml contains 0.157 grams, right? So this 100 grams contain this much. So in 100 grams I have dissolved this much of salt. So I can say indirectly this much of salt contains 0.157 grams of vitamin C. I hope you understand this, and if you have any of the queries related to this, you can write me in the comment section. Thank you all. Thanks for watching.